Welcome to my session, Architecture Blueprint for SAP Leonardo IoT. My name is Tim Buck, and I'm a Chief Development Architect in the Leonardo IoT area. And in this talk, I will present the features, the technical components, and the architecture of Leonardo IoT. We've got quite a number of slides and a couple of applications to show you, so I'll hope I'll make it through all of them. Let's first have an introduction to Leonardo IoT. And at the very beginning, we have to look at the overall picture, how Leonardo IoT is embedded in SAP strategy. So SAP strategy at the moment consists of three key components in the so-called intelligent enterprise framework. So the three key components are the intelligence suite. That's more like your traditional system of records applications, application suites like people engagement and of course customer experience, but also manufacturing and supply chain management, which is very important in the IoT area, of course. So if you've got your applications there, and these applications, you've probably heard it a number of times also in the keynote, are actually enriched with intelligent technologies. So, for example, the Internet of Things, so the topic that we'll focus in this talk, but also with machine learning and complex analytics on top of it. All this rests on the third key component, the digital platform, which for one is the cloud platform. So Leonardo IoT, in the most part, runs on the cloud platform. We'll see there's also a so-called edge component. And then there is data management, which is very important in IoT because we're potentially looking at loads of data, so we are in a big data space here. Let's have a first look at what Leonardo IoT is. Well, IoT is obviously at its center about sensor data that's sent from devices. So with Leonardo IoT, you can virtually connect any kind of device to your system. So the device could be as small as an Arduino or a Raspberry Pi up to pretty big machinery. So anything can be connected. And we've got solutions, I already said, in the cloud, but also on the edge. The edge is a term of a computer that sits near to the devices. So that's rather on-premise, you could say. It's an edge computer. What's important about IoT is you get sensor data. We'll look at this obviously a lot in this talk, but just this sensor data is not enough. If you measure temperature, you have to know where the temperature comes from. So you have to have some what we call semantic integration into the applications. We'll talk about this a lot. So this is where the enrichment comes from. I mentioned it's a lot about data management. We have to process and we have to store potentially huge amounts of data. That's also part of Leonardo IoT. So with this semantic enrichment, we call it also contextualizing of the IoT data, you can then start your processes on the data, the intelligent processes that I mentioned before. That might be either simple rules, but that might also be machine learning and AI. So you can train models on the data that comes in and apply these models on it. And it, of course, is also analytics, where you dig deeper into the data and find out certain things about the data. Now, how is that at the end embedded in your applications? Well, there's different ways that's happening. So for one, IoT can be embedded in a traditional application that SAP ships, but there are some applications which are almost entirely driven by IoT or mainly driven by IoT, for example, predictive maintenance. But what's also very important is that a lot of IoT use cases are very special for each customer. So a lot of customers need to build their own applications, and we've got capabilities to build your own applications, which SAP doesn't ship. This is a first look at the components that make up Leonardo IoT. So first of all, you see there is an edge solution, the SAP Leonardo IoT Edge. We'll cover that more at the end of this talk. At the beginning, we look more into SAP Leonardo IoT, which is the cloud solution. And you see there are a lot of components in there. One of the big things is the data ingestion. So you connect your devices to the system. And then the data ingestion is what we call basically processing the data as it enters the system before it's actually stored. Then we store the data. We'll have a number of databases, which we'll see later. And then there's obviously a lot of services on top of the data that's actually streamed into the system. And these services are used in the applications, again, either embedded in existing applications, driving applications almost entirely, but also in your own applications that you can build. Right. So before we now look into some of the components more deeply, we have here like quite an overall architecture picture, which, well, not only covers basically all the components we're going to talk about in this talk, but also shows a bit the flow of data, what's happening with the IoT data. So it all starts at the left side with numerous devices. And the devices need to be connected to the system. And that can be happening in numerous ways. Let's first start in the middle here. You can connect the devices directly to our SAP Cloud Platform. Some of you might know Cloud Platform, there is a Neo solution. This is not something that's happening or that's needed for Leonardo IoT. We run completely on Cloud Foundry. So we have a complete cloud solution here, and the data gets in to our first component that's called IoT service. Here, just on the left-hand side of the Cloud Foundry box here. IoT service is our very own component for device and connectivity management. So it speaks HTTP and MQTT, and you can send your data, your sensor data into the system in a secure way. But there's also other possibilities to connect to Leonardo IoT, and you see that down there. You've heard it, we've now got like big alliances with AWS and Azure. These two vendors also have strong IoT offerings, and some customers would like to use the device and connectivity management from these vendors. They can do that. You can have your own account there, and you can send the data from there into Leonardo IoT. So that's also a possibility. The third option is the edge. I mentioned it already. The edge is a computer that sits near to the devices. And it's something where you can already process the data. So in a lot of cases, which we'll look at later, you do not want to send all your IoT data into the cloud, but you want to do something with it, and you can do mostly the same things that you later see that you can do in the cloud, you can also do it on an edge computer. So we've got a solution for that. It's the so-called Edge Services that sit on top of an IoT Edge platform, as it is called, which is a part of the IoT service module. Maybe not that important at this point, but just to mention it. Then the main parts of Leonardo IoT come up, which is the storage, the big data storage. It's the processing of the data as it gets into the system, and it's the services on top of them, which we'll look into. Then when we've got the data, we've processed it, and we stored it in a database, we've got services on top of it. What you normally want to do is, just the data is a bit boring. Very often you want to start some business process. For example, if you measure a temperature, and we'll see this in some examples later, and the temperature goes above a certain threshold, something is wrong, you need to create a service ticket for someone to look into this. So this is something that you can do with Leonardo IoT. You have a connection to your backend systems with numerous technologies. For example, SAP's cloud platform integration, where you can just from Leonardo IoT, if something happens, if a threshold is met, you can create a service ticket in your backend system, for example. Okay, then we have a number of tools. You see at the bottom here, the tools are basically to set up the models in Leonardo IoT. So Leonardo IoT, you'll see later, you don't have to program a lot, but you can do a lot of configuration. If you want to create your own application, though, you have to program, but we have something, some of you might know the Web IDE, to create Fiori-like applications. And we've got some special plugins there to create IoT applications so that it can be done really easily. Now let's go back to this picture and pick the first components with a bit more detail. So it's mainly about master data and semantics. You have to create models, kind of your software representation of the device. Sometimes it's also called the digital twin in the system, and you have to model that first. And so this is something we'll take a look at. And then there are geo services and the floor plan. I just briefly mentioned this at the moment. You can create points of interest, area of interest, and floor plans. And you can group them in hierarchies. For example, what you can actually create is something like a location that has a number of buildings, and the buildings have rooms, right? Why would you need something like that in IoT? Because, for example, you want to do some geofencing. You want to see when some device leaves a certain room, for example, or enters it. That's very often a use case that people need. So I talked about modeling. And we get to the first model. We actually have two big models. The first model, the so-called device model, that comes up if you are using IoT service. That, if you remember that from the slide that I had before, that's the component that does the device and connectivity management. So what you have to do there is actually create a model of the data that you want to send into the system. So let's say you have a device with sensors that there's a temperature sensor and a pressure sensor, and you want to send that temperature and pressure into the system. You have to model that in IoT service. You do this with the device model, you do this with properties. So temperature and pressure be properties. These properties you can group in a so-called capability, a bit of a strange name. You can think of the capability as just a group of properties. So 1 to n of these properties you can put in a sensor type, or you have to put in a sensor type, which is kind of a template for a real sensor. You have to be careful. Sensor here doesn't mean just one value, as you would like say in normal life. Sensor can be a number of values, temperature, pressure, and a lot more. 1 to n of these sensors would be making up a device, and the device would be part of a gateway, and that means you either speak HTTP or HTTPS to be precise, or MQTT. So you see there's a lot of modeling capabilities for you. At the center, it's properties, and it's all sensor data. And this model, we say it's a technical model. Now we get to the next model, the so-called thing model, which is at the center of Leonardo IoT. The thing model is the model where applications are being built on. And as opposed to the first model, the device model, which is the aspect, the thing model is more the semantics of the device. As opposed to the device model, which only consists of sensor data, the thing model also has master data. So it has sensor data or measured values, and it has master data. You can set up any properties there as well. You could say the device has a location, the device, for example, has an owner or description. That kind of master data you can create for the device, for the thing. Here we also have properties. Again, if we go back to our example from before, properties could be temperature and humidity. These are grouped, again, a strange name. Before it was capability, now it's called property set type, but again, it's a grouping of properties. A property set type would be, again, put in something like a named property set type. So here's an example. A property set type is a tire, pressure and temperature from a tire, but in a car you've got 4 tires, 2 in the front and 2 in the back, so you would have 4 named property set type. That is what this means. And all of these make up a thing type, which would be a car, for example. And then there are things, which are the instances of that type. So you've got a thing type, which is car, and then the individual car is a thing. So that might all be a bit confusing. So, you know, the property part, I think that's clear, but why do we have 2 different models? The main reason is, if I'm honest with you, the IoT service module came the device and connectivity component came with its own model, the device model, and the thing model was another component, and you could use them independently from each other. So in a lot of use cases, frankly, it's a bit of a pain that you have two models. But in some use cases, there's actually a lot of value in it. Because if you, again, think about the device model as a technical model, and the thing model as a semantic model where an application is built from as well, the device might actually change, right? You might change a vendor and they might still send temperature in your system, but in another way. Maybe one property is called _T. In another device, the same property is called temp. But in the application, in the thing model, you want to use temperature. So you change the device, for example, you don't have to change the application, you just have to change the device model. But the fact that we have two of these models means that you have to map them, and you do that in an application, right? So maybe let's just quickly show you, so this becomes a bit clearer. A timeout, obviously. I hope this is not a problem. So first of all, let's have a look into the IoT service cockpit. That's where you create the device model. You see devices, sensors, sensor types, and capabilities. Oh, you don't see anything. It's just, oh, sorry about that. I have to, let me quickly press escape there. Okay. Now, that's much better. So now you see the IoT service cockpit. The IoT service cockpit has, as I mentioned, devices, sensor types, and capabilities. So for example, a capability here, or let's come from a device. Let's take Power Drill 01. So we've obviously modeled a power drill here. It has a sensor, and that sensor type has a capability. And so in this case, we have like three properties there: temperature, drill impact, and battery level. Yeah? So that's kind of a data dictionary for the device. Then for the thing, we have a thing modeler, right? So I told you about the thing type. So here we can see the thing type, and as opposed to the device, for a thing, we can also have master data. So here we see basic or master data, and we have measured values, which in our case are basically the same properties as we had in the device. So going back to, not this. Okay, going back to the slides, we need to map them. In the same application that we just saw, the thing modeler, you can define a mapping. You can say which property of the device type maps to which property of the thing type. Okay, but we've got much more on top of these kind of normal properties. Some of them already exist, some of them are planned. What we have, for example, is thresholds. For each of the properties, you can define a threshold. Let's take the temperature example again. You could say the temperature must never go over 80 degrees. What we also have is aggregations. We'll talk about that much more in a later part of this talk. At the moment, we create aggregations automatically, but in future, you'll be able to say which kind of aggregations you want. For example, you can say, I want my average temperature or my min and my max temperature in a given time frame created by the system automatically. Then we've got associations. Think about a thing type car and a thing type trailer. So you can define your own association, which is attached to. So you could say a trailer is attached to a car, and that could be time dependent, and you can change it over time. So stuff like that you can do. Then we have derivations, or we plan to have derivations. That's actually very interesting. That's calculating new values from sensor data as the sensor data is streamed in. For an example would be some drillers, you have an X, Y, and Z accelerometer, and then you can calculate from that whether you actually drill a hole into the wall, in the ceiling, or in the floor. And we've learned that from one important customer of ours. That's really important, because if they find out that you drill too many holes are actually drilled into the ceiling, and so the driller is like that all the time, you need a different lubrication, and you might actually have to create a completely new model that actually can take this use case. So that's a derivation that happens. Okay. Then we have some attributes for the UI, labels and enumerations. Not that exciting really, but the last bit again is, because again, just having a temperature or all these sensor data is not enough. And we'll see in the next example, you usually need to know what the context of the temperature is. It makes obviously a big difference whether the temperature comes from a cooler or from a car. And so we have a lot of possibilities in Leonardo IoT to contextualize the sensor data. You can actually make that also time dependent. For example, you can say for a given time frame, there is a business partner associated with the time series data, and that can change over time, as I said. But that's also for the storage location and all the other stuff that you see in these bullet points. To become a bit more concrete, let's go to this slide. So we have a silo there, and let's just think that the silo has a sensor that tells you about the fill level. So again, the fill level alone is not enough, because whether you have 1 meter left and you have a big silo or a small silo obviously makes a big difference. So you have to know the type of the silo. Then what you also need to know is what kind of material is in there at a given point. There might be different materials in there. The material might also have a consumption rate. So if you need a lot of that material, then the fill level needs to be much higher before you start your next process, which would be a replenishment process, for example. So creating a purchase order for new material in your silo. So that's the kind of context that's very important, and then that you can create with Leonardo IoT. Okay, so let's move on to other topics like the data ingestion, the big data storage, and time series management overall. So at the very beginning, I said we've got several databases to store data. Why is that, and what are they for? Well, first of all, every sensor data that's sent into the system is stored in 2 different databases, in the so-called warm store and the cold store. The warm store, which is currently a Cassandra, a big data technology, is usually quite fast in its read access. It has a certain level of SQL capabilities, but it's quite expensive. All of these components, apart from HANA, you could say, but are big data components, so that's important. So they come with stuff that you need for, like reliability, being able to process enormous amounts of data, failover, all the stuff that comes with big data and cloud qualities. But the warm store, as I said, is quite expensive, but quite fast. The cold store is the opposite. It's much cheaper, but read access is much slower and even less SQL capabilities. So normally when you read data in an application, you'd rather take it from the warm store. But as it is so expensive to keep that data in the warm store, we've got a retention time. So as a default, after 3 months, the data is deleted automatically from the warm store, whereas in the cold store, it stays until Kingdom Come or until you actually delete it with an API, but we don't delete it. So normally months here in the warm store and years that you keep the data in the cold store. And then we've got a hot store. And a hot store is something that has aggregates. I mentioned before that Leonardo IoT automatically creates aggregates. So for everything, for every numerical property where sensor data is sent into the system, we automatically create a number of aggregates. You see some of them there, min, max, average, for example. And we do that every 2 minutes, every hour, every day, and every week. So-called pre-aggregates. Now, what is that good for? If you think of an application that where you want to see in a UI, you want to see the average temperature of the last year. If we now think of a database where the temperature was measured every second, let's say, and we would go to Cassandra and try to calculate the average temperature over a year with that enormous amount of data, we'd be waiting a long time. And as a user, you would not accept that. And that's why we have these aggregates, because we can create the pre-aggregates. We can create the aggregates of a year really in a fast manner using HANA with the pre-aggregates. So it's basically that you get a reasonable response time in an application, right? And in most cases, that's important, you are actually interested just in the aggregates. No one usually cares about what the temperature was yesterday at 4 o'clock. You normally want to know what the average temperature was yesterday, right? And that's why these aggregates are so important. Let's go to the next slide. That's the ingestion. So ingestion is processing data as it comes in. That's what ingestion is in IoT. So you see again a couple of components. So this is more again technical. You see the IoT service, or the official name of IoT service is SAP Cloud Platform Internet of Things. That's the device and connectivity management. That gets the data, it sends it into a message broker, Kafka at the moment. What is that for? Well, the message broker is something that can take a huge amount of messages at the same time. You might have a lot of devices connected, and there might be some peaks where all of them send data into your system. Kafka can take it all on. It doesn't fail when it gets that much data, and it just buffers it for the follow-up processes. So that's a component which makes sure all the data that's sent in is not lost, right? Whatever the other components afterwards do, right? Then we go to the main ingestion pipeline, which at the moment is either in Spark, another big data, best practice big data component for distributed computing. So what you can do in Spark is you can do a lot of calculations distributed over different nodes. So again, it can take a lot of data at the same time and processes it. So what is happening there? Well, first of all, the mapping of the models, the device to the thing model is happening there. And then rules are executed. We'll cover the rules later. Something which is dashed here is transformation and derivations, because we don't have it yet. What is transformation? Transformation is, let's say, something sends in miles per hour, speed in miles per hour, but you want it in kilometers per hour in your system. That would be a transformation of the data. Derivation of data, we already talked about, that was the drilling into the ceiling and the wall from X, Y, and Z accelerometer. So then the data is stored, warm store, cold store, and we calculate the aggregates in the hot store. But on top of it, you always have, and that's like the first time that you see this, you have APIs, right? So the application doesn't really know about the different storages, or very often doesn't know about the storages. It just knows about the APIs, and the APIs then access the database. And on this picture, it's important to also see one of the differentiating factors that Leonardo IoT has compared to other IoT vendors. Other IoT vendors also use some of these components, but what you see here with Leonardo IoT, you get out of the box, right? So with other IoT vendors, you have to make a decision. Do you want a warm store? If yes, what kind of warm store, what database you want to use, and you somehow have to stitch them all together, right? With Leonardo IoT, that decision has been made for you. It's important that you understand what's underneath, but you don't have to make that decision, and maybe actually do a lot of programming to stitch the components together before you actually get to your real use case. Yeah, so that's a different thing in Leonardo IoT. So I mentioned the APIs without going into too much detail. Just some examples. We have different APIs, REST or data. We have APIs where you really do not need to know whether data is in the warm store or if it's still in the cold store, or already in the cold store. Some other APIs, you can access the cold store or the warm store directly. So we have a huge number of APIs to handle the data in the databases. Okay, now let's go to the next bit. First, it's like the onboarding and device management, and then something about what we call lifecycle management. So I've mentioned already our very own device and connectivity management, the IoT service component. A bit more about this. I already mentioned that it can speak HTTPS and MQTT. What I haven't mentioned is that it also provides the security for devices. So for a device, you get a certificate, and that certificate you put on the device. And that's how Leonardo IoT knows that this device is actually an authenticated device, and it's actually okay to take on the data from that device. And it has the device model that we talked about at the very beginning of the models. But as mentioned at the beginning of the talk, a lot of customers now are asking us, or were asking us, can we actually use the device and connectivity management from AWS and Azure? AWS and Azure both have strong connections to also sensor vendors, and they want to leverage this advantage of the device and connectivity management components from the hyperscalers. So we've now, since about half a year, enabled that possibility as well. So customers can set up their own AWS or Azure account, use their device management, and then send the data into Leonardo IoT, still getting the contextualizing of the data that we talked about before, rules and so on, which we'll cover. So you get all the other benefits of Leonardo IoT. Some more words about this. I mean, without going into too much detail, how that is done at the moment. In the thing model, you have something like an alternate ID, and that would be the ID of the device on the AWS or Azure side. As with a device model from IoT service, obviously, they also have their data format. They also have something that they want to send into the system. At the very end, we always have a thing model, so also some mapping needs to happen there. So mapping from their model, so to speak, into ours. Customers can set that up as well, as they can with IoT service. I think it's fair to say at this point, there are a couple of restrictions when it comes to the throughput, for example. You can't really scale that much with that solution at the moment, but we're working heavily on this to change this, right? So you can expect a lot of improvements there. Next is what we call lifecycle management. Just briefly, we've got a message broker, so something that you can subscribe to and you can listen to if any of the things or the master data of the things or the metadata, so the thing types, if they change, then you can change also some other connected objects that you might have, and you can program on that. It's just a minor thing. Now let's get to something that's rather new, but obviously essential. It's rules execution. And we have two different kinds of rules. We have streaming rules, and we have scheduled or batched rules. So streaming rules are rules that are carried out in the ingestion pipeline. So they are carried out when the data is processed before it's actually stored. The scheduled rules work on the database. So first the data is put to the database, and then scheduled rules run that's where the name comes from, in a scheduled way, periodically. Yeah? And you can set up what that period is when the rules run. Right? So these are the differences, and we have both of them. You might wonder why are there two different kind of ways of executing rules? Why is there streaming and batch rules? Well, first of all, at the moment, there's different possibilities where stream rules only work on the time series that's sent in for just one measurement. So one temperature, for example, and one humidity. You set up a rule, say if the temperature is greater 80 degrees, then do something. With the batch rules, you can do windowing, as we call it. Windowing means you can look at a number of measurements. For example, all the temperature measurements over an hour. And you can say, I only want to fire a rule when the temperature was above the threshold 6 times or something in the last hour. That's important in IoT normally. You can, at the moment, only do that in the batch rules. What you also get in the batch rules, you can select much more dependent master data. So the temperature is bigger than 80 degrees if silo type equals something, right? So something like that at the moment is only possible in batch rules. Now you might ask, what do I need streaming rules for? Then streaming rules obviously are more immediate. The data comes in and you can do something immediately. You don't have to wait for a period. And also, we will improve this a lot. It's actually less strain on the database because you don't need a database. If you can do something in streaming, the data comes by anyway. You don't have to do a select on the database all the time, which can also be quite straining. So again, here you see a concrete example. The streaming rule, you see, works before or basically in parallel of the ingestion, whereas the scheduled rule goes to the time series store. It can only run if the data is already persisted. And then you also see the difference here. You can say, if we take it as an example, the coffee machine, if the fill level is less than 160, whereas and the brewing unit is blocked, so it's blocked at this moment, then the rule will be fired. Whereas if you look at the scheduled rule, it says if the count of so the number of the blockages in the last 10 minutes is 2, then I will fire this. So if it's just once blocked, you don't want to do anything. Sorry. Another feature that we have is, if you look at this, for example, if you have defined a threshold, which is this line, and there's a sensor point that is below that threshold, you fire the rule. Now, another sensor point comes in. You don't necessarily want to fire the rule again. If something is broken, it stays broken. You don't want to, every time the rule is actually met, start the business process again. For example, create a service request, which we will see. So you can define rules as sleeping or toggle rules. Sleeping means you define a period up to 1 hour until when the rule is met, it's fired again. Whereas toggle rules is you first of all have, after it's fired once, it needs to once not meet the condition, and only when it meets it again, it's fired. So that's what toggle rules are, and that's something that you can set up. Now, let's get to actions, and I'll show you quickly in the system what the whole thing looks like. Actions is a way, well, it's a framework that we have where you can configure actions on the rules. So a rule is fired. You want to do something with that. The result of a rule normally is an event. We create events, and we'll see this in the next slide. And the event can be picked up by our action framework. So the action framework can do a number of things. It can, for example, create an in-app notification in the Fiori Launchpad, or it can send an email to someone, or I think most importantly, it can also call APIs, for example, in the cloud platform integration, and start a business process there. If the temperature is greater 80 degrees, create a service ticket in C4E, for example. Then a bit of technology. I said all the rules, streaming and batch rules, they always create events. These events are stored in Kafka, so again, a message broker. So some consumers can listen to these events. Our standard consumer is the action framework, but we will also create the possibilities for you, the customers, to actually program their own consumers on events. You might want to do something completely different. These events are adhere to the so-called cloud event specification, a public specification to unified events over all vendors. And this specification will at some point go to the cloud native foundation. So let me show you the rules in the system. Okay. Again, what happens here is, because I've been inactive for a while, I've opened all these applications, but because I've been inactive, there was a timeout and I need to reload. I just do this. This is how you define rules. So for our example that we had at the very beginning with the power drill, you see there is different rules set up. Let's take the high temperature rule, because we talked about temperature all the time. So you get into this. You see there is a rule defined, and what's the definition of the rule? If the temperature of the drill sensor is greater 80, then create an event which is called high temperature. Yeah? So that's one of the rules. And there you can also say where that rule is carried out. So the action framework that we just talked about, I also have to reload the page. Bear with me. We've defined an action on the temperature. So let's go into this. And here you can see this action is triggered by an event from a rule. Which event? It's the high temperature that we just saw in the other example. And what does it do? In this case, it calls an API in C4C. So it uses, you can see this here, it uses the cloud platform integration, or some of you can see it because HCI is the old name for the cloud platform integration. And it calls an API, and it creates a service ticket in the back end. So you can see it's really easy for you as a customer to set up rules and actions. You don't have to program anything. You just go into these UIs and configure it, right? But you can also program your own stuff, but you don't have to. That's the important bit here. Okay, then a quick look at the Web IDE. I told you at the beginning, in a lot of cases, customers want to questions we'll take at the end, okay? In a lot of cases, customers want to create their own application, yeah, based on the APIs and the configurations that I've shown you. There's the Web IDE with which you can build Fiori applications, and we've got a plugin that's exactly tailored for IoT applications. We've got a couple of UI5 controls which are also tailored for IoT, for example, a sensor chart. With a sensor chart, you can very easily see all the sensor data of a given period, and you can very easily drill into different time frames, and our APIs are called in the back. With the Web IDE, we've put a lot of effort into making it really easy to create like a demo or a start of an application. So you get it all via what you see is what you get. You just drag a couple of controls and create also something called actions, so to kind of wire the control, so you don't have to program anything to get something running really within a matter of 2 minutes. The good thing about the Web IDE is, and normally that's why I'm saying it's a demo or to start something up, you're usually not finished. You might have then 80% of an application, but the last 20% in that application, you have to program something, and these are the hard ones. You just switch in the Web IDE and you get the code. I mean, that's a feature of the Web IDE that's not specific to IoT, but then you can finish your job there. So that's the Web IDE. So you can create your Fiori applications, but it's important, you don't have to create your a Fiori application. I mean, we've got customers that create mobile apps, and they use a completely different technology to do that, but they use our APIs, obviously, from Leonardo IoT. The last part of this talk, let's go to the Edge services. So we've now finished the cloud part. Now we go to the Edge, which I mentioned is a computer that sits near to the devices. So first of all, why? We've now learned that you can process and store all this data in the cloud, and now there's something like the Edge. Why would you actually choose to do that same-ish kind of stuff that we'll see on an edge computer and not in the cloud? So what are drivers for that decision? One of them is data volume and bandwidth capacity. For example, think about a locomotive. I've seen that before. They have like 5,000 sensors, and they send each, or they get the sensor values each second. You can imagine it's an enormous amount of data that's produced each second. And you don't really want to send all of this data into the cloud, right? It's very expensive, and it's not needed. So you rather process a lot of it already at the locomotive. So the locomotive could be an edge computer. That's one reason. Another is the infamous oil rig. You might not always have connectivity, right? And you can't send anything into the cloud, but if there are highly critical processes in your business, you don't want to wait for the connectivity to come back. By that time, maybe the oil rig is completely gone or something, so you'd rather process that data on the edge. And the last one is the real-time decision making. We've talked a lot about rules, how if the data comes in, you do something, but in some cases, in the cloud, that might be too slow, because in the cloud you always have a latency, and you have some processing time in the different modules that we saw. If you want to have a use case, for example, where the sensor data actually controls something, for example, steering a car, right? Because of sensor data, you certainly don't want to do that steering in the cloud. You do it where the data, where the sensor data happens, and that would be an edge computer near to the device. So these are drivers of the whole thing. So what do we have with edge services? Well, first of all, we have a couple of components, again, that sit on the edge computer. We have a so-called edge platform, which is a foundation. Edge platform is the connectivity of the edge computer to the device. Here, I mentioned before, in the cloud we can have HTTP and MQTT as protocols. With edge computers, we can have many more protocols, and there's a lot that we'll already ship. But if you have your own protocol, you can actually program it on this edge platform, which is a foundation. And then we have some higher level services that we call SAP Edge Services, Leonardo Edge Services, essential business functions, streaming service, predictive analytics, and the persistent service, and we'll look into these services. So these all run on edge computers, on-premise more or less, but you always have a cloud component, which is the policy service. What is the policy service? Well, if you now think you have got edge computers, let's say you've got 100 of them, and they all run this software, you want to make sure that you have one place where you control the life cycle and the configuration of this software, right? And that's in the cloud. So you configure the life cycle with the policy service in the cloud, and this service makes sure that all the edge computers have the same level of the software, the same version of the software, and the same configuration. So that's the policy service that's always in the cloud. An example how that can be used is that you might have like completely different edge computers here called gateway. Gateway is another name for such computers. And you can group them with certain specifications. And then you can have different configurations for different groups of gateways or edge computers. And the configurations are being taken care of by the policy service centrally and just sent to the devices. Okay, then we look at the streaming service. Streaming service is like the ingestion in the cloud. We also have rules there. We have built-in rules where you can easily configure these rules. Then you have something a bit more advanced than what we have in the cloud. You can program your own rules based on something called CCN, Continuous Computation Language. It's basically like SQL on a window of data, and you can program that stuff, and you can have third-party logic where you completely out of the blue create your own rules and can intercept the data. But this is like the first time we see, okay, so you can do something in the cloud, and you can do it on the edge as well. Yeah? And you have to take a decision where you want to do it. We'll revisit this in a second. Then we have a persistent service. I mean, obviously, with these edge computers, we are not talking about big data, but it might also be a lot of data, but not big data. We have a database that sits then directly on the edge computer, REST APIs to access that data, and you can build your own applications on that persistence. So again, in the oil rig, for example, if there's no connectivity, you want to store the data before some of it actually goes to the cloud, maybe. You want to store it in a persistency there and later on get it in the cloud. Next one, a very important one, is the Essential Business Function Service. A bit of a weird name, but what it actually is, it gives you access from the edge computers to your backend systems. That might be traditional ERP systems on-premise, but it can also be S/4HANA in the cloud. It's also, some of you might also know from digital supply chain management, Asset Intelligence Network. We have a connection to that as well. What you can do with it, you can, on the edge, with this connection, either trigger processes. For example, you can create service requests or purchase requisitions already on the edge computer. And you get some context, because what's important in the cloud is also important on the edge. You might get some additional master data from your backend systems running on the edge. So you kind of can imagine that there is the data is mirrored on the edge, and there's a synchronization process when it's possible, when there is connectivity from the edge computer to the cloud. Yeah. And then last but not least, we have a predictive analytics service where you can run your machine learning in the cloud mainly, or in a backend. For example, SAP's predictive analytics. You create these models in the cloud, and then you can actually put them on the edge computers and run the models there, the finished models there. Then you've got it. I know it's an enormous amount of slides, and I hope I haven't put you to sleep. I know it's a lot. Also with the edge, as with the cloud version, we now got an interoperability with the hyperscalers, Azure and AWS. Azure Edge and AWS Greengrass are runtimes that you can run on an edge computer. A lot of customers already have that, want to use that, want to leverage that. But they also want to get like the context of their SAP backends into this. And that's why the Essential Business Function Service that I mentioned before, which gives you that connectivity to the backend systems and which mirrors the data on your edge computer, is available as a Docker container. You can get that Docker container from the SAP Container Registry using our policy service. It's then the policy service knows which edge computers exist from the hyperscalers, and then you can put this container into your runtime of the hyperscaler and use this as well and leverage the connectivity to the backend. So now the last slide, quite exciting, more like an outlook, is if you have like a hybrid of edge services and our cloud solution. So you run both. You run edge computers, but you also have a cloud solution. Why would you want to do that? Because let's again take this example of the locomotive with the 5,000 sensor data. Some of the data you do not want to have in the cloud at all. You want to process in real time directly on the locomotive. You do that there. But some other data you might actually want in the cloud. You might not want to have it like every second. You might want to have it as an aggregated value or so. So you can create these aggregated values or lower sample rates, you could say, on the edge, and just send the gist of it more or less into the cloud then, where you then do analytics across all of the devices. Because when you use an edge computer, you only have a section of the devices, right, that are connected to these. So you've got some use cases where you want to do some of the stuff, some of the processing on the edge, and some of the processing in the cloud. And you are the one that actually decides what happens where. When it comes to the rules, we are working on the possibility of creating the rules like we've seen them before in the application. And you can then say, I want to carry out this rule in the cloud, or I want to put it to the edge computer and run it there. With that, I'm at the end of the talk. I just want to mention that if you want to see less slides and more of demos and see this, how this runs, there is another session tomorrow at 4 p.m. from my colleague Martin Ebert, and he will go through an hour of demo. So if you're interested in this, please go there. Then we also have usability tests. I understand that there is one place left tomorrow. If you want to have a look at the rules and the actions that you saw and how that works in the UI, please sign up for that as well. So with that, do you have any questions? And if you have questions, I think you should wait for a second until, you know, the nice gentleman gives you the microphone, hands you the microphone. That's because the session is also recorded, so everyone can hear the question. So yeah, this gentleman already had a question earlier on.
Maybe you can answer very quickly. You mentioned there is streaming rules and batch rules. Do you have to decide whether to use one of them, or can you use both parallel?
And run them in parallel, yes. In this case, why you want it different, right? We've seen this before. Maybe if we look at the blockage of the either you create the event when it's blocked just once, or maybe if it's blocked several times in a window, both, but it's possible. You can do that.
Could be that you say, I don't know, when the temperature exceeds 80 degrees, as you said, 6 times in a minute or so, or 6 times in an hour, then I have to react on that. But if it exceeds 90 degrees, I have to react immediately.
Yeah. But that's definitely possible. Yeah, that's a good use case. That's possible. I forgot to mention one thing, that actually one of the possibilities of actions is to create yet another event and then follow-up actions. That's also possible. Yeah.
So test. Yeah. Okay. I have the question. I have actually 2 questions. First of all, what was the background for the decision for Spark instead of Kafka Streams, if you're already working on Kafka?
Not entirely sure. We've looked also in Kafka Streams, and as you, I mean, it seems you know quite something about this. There is other options as well, Flink, and basically, I haven't mentioned at this point, we're also looking into SAP's Data Hub vFlow solution as a pipeline engine. That's probably what we're going to do next. But Spark at the time just seemed to be the best of them all. I mean, it's obviously more complicated than Kafka Streams, and I'm not entirely sure if, I have to admit, at the time when the decision was taken, Kafka Streams was available as such. What definitely is the case, Spark is offered by our cloud platform. Kafka Streams aren't. So that's the very easy answer, but Kafka Streams would also be an option to use for this kind of task. Yeah, fair enough.
Then second question.
Second question, yeah.
Can you also use this SAP Leonardo for different use cases as Internet of Things, like, I don't know, let's say banking or something like that?
You mean whether Leonardo IoT could be used for banking? It's an interesting question. Well, before we had a discussion, you know, how there was a lot of hype about IoT. And very often people ask about the use cases. And we had a discussion beforehand with a nice gentleman who said in a lot of cases it's probably important to drive the technology, to make the technology available, so people can think of more use cases that we have not thought about. Maybe this is in this category. So, I mean, it is possible to use it for anything, right? Even a device, if you think about it, I said the device needs to be connected and send something in the system. What it really is a program that does an HTTP call with something, with the time and some properties. I think there's probably other stuff that one can think about which doesn't really immediately, you know, come to mind, and maybe something like banking is. We had a discussion before where people looked at bills, like trying to get the different entries of a bill, putting it in a time series store. It didn't completely fit, and they decided that was SAP internal. They decided not to take it, but it goes a bit in that direction. So anything is possible with this. Yeah.
Thank you very much.
Thank you. In a scenario with Leonardo IoT used to be the data lake of data.
Was the question whether we have a data lake of data?
No, if this database database, not data, a data lake, could be access to this data not only with API, but in the future could be an open.
So again, your question is, someone has, for example, a data lake with data. So the data lake, for the rest, definition of a data lake is you basically have all kinds of data, unstructured data, or it's usually not unstructured, but the structure you don't know. Can we use that as well? Can we access the data lake directly, or does it always have to be an API? Well, as you've seen so far with Leonardo IoT, we don't have a connection to any of these data lakes, and also we don't let you go directly to the databases we have on offer, so you can't go to Cassandra. But you can imagine even SAP internally, a lot of application developers do not like that, and also people want to get access to data lakes. So there's a lot of thinking about it, and also so first of all, being able to access the databases directly, possibly by views, but also to connect time series from data lakes or from historians, as we call them, in IoT. The latter, I'm pretty sure if you come to this talk next year, I can tell you much more about it. Yeah.
Thank you so much.
Okay, then thanks a lot, and hope this was helpful. Thanks.